I guess we can start. Hello everyone, I'm super excited to be here and I'm glad that you guys showed up because first and foremost it's the last talk of the conference, so I assume you are super tired, and even though it's Devoxx, it's 33 degrees outside, so it's kind of hot. And most importantly, I have a huge competition in the room number 1, the great Venkat, the showman. So thank you very much for coming again. This is a very special place for me because I grew up just around the corner, and I remember that right here, where this conference center is, there was literally nothing. There was just a kiosk and a bus stop and a bunch of my friends killing skateboards. So it's pretty huge progress, I must say. So the title of this talk is Let's Develop on Prod. Wait, what? It's a bit provocative, I must say, but my goal here is to show you tools and techniques which actually brings you very close to this goal. But before we dive into interesting things related to cloud development, I thought I'm going to open up with a motivational quote, which you can find everywhere on Instagram, so I thought I'll try the same. And the quote is from Edgar Dijkstra, one of the most important computer scientists of our times, who said, if the debugging is the process of removing software bugs, then programming must be the process of putting them in, which in fact is actually demotivational, if you think about it. But we are human beings, so we do mistakes. And hopefully we learn from them. And bugs are actually mistakes in the process of transferring our thoughts into the code. There are some funny bugs, like the one which showed up in FIFA, where you had this ridiculously huge goalkeeper running around and you could score as many goals as you wanted. That's an easy glitch, probably was shipped with yet another 40 gigs patch over the network. And there are those which are a bit more serious, where you can put an image of your company in threat and lose credibility. One of them happened to Apple back in 2012 when they released Apple Maps. It turned out that they show a lot of places looking very strange, and maps were actually guiding you to nowhere. And we as software developers have a lot of tools in our tool belt to actually prevent bugs from happening. We can use strongly typed languages where a compiler can actually help us spot some weird stuff we put in. And we have a lot of techniques around testing where we can write unit tests with mocks, with stubs, with other test doubles, so we fairly quickly can know that we screw up something or that we introduce some regression. We do have other levels of tests like contract tests, which are quite popular these days. We have integration tests, system tests, end-to-end, you name it. We have a lot of good tools in our disposal to gain confidence that the feature we are about to ship will not break. But the ultimate question always is, will it work on production? And back in the days where we were working with monoliths, things were fairly easy, because we could have a setup which was fairly close to production. It was all self-contained box where we could start up everything. We could easily debug and reason about it. We were fairly productive. But as it turned out, even though we as developers were happy, we weren't ready with this architecture for the web, which was growing like crazy. And the scaling issue came out fairly quickly. I guess most of you remember this little fellow who was showing up when you were using Twitter, when they were running the Rails monolith. So the scalability in the web times was not really something where monoliths could give you for free or were easy to accomplish. So we, as an industry, quickly realized that we should change our approach. And we proposed something which is called microservices. Others call it service-oriented architecture. But with the microservices, we mitigated a lot of the challenges which Monolith brought. So the scalability was one thing, but also the important aspect was scalability of the teams. With smaller, fine-grained services, it was easier for always growing teams to actually develop and ship features easily. But there are always some trade-offs. We changed one set of problems to the other, or as we say in Polish, the uncle changed the axe to the stick, right? So coming from the monoliths, we came to work with microservices with few assumptions, which are fallacies of distributed systems. We assume that network is reliable, so it's always there. There are no infrastructure issues or whatnot. It works. The other thing is that the latency is zero, so we get instant responses. Everything which we send, we get back, like with monoliths in memory, super quick. And that the bandwidth is infinite, so we can throw as much data as we want, and we still can get the responses as we wish. And that it costs nothing. But on top of it, the most important aspect for all of us developers was that we were productive, that we could write the code and we don't have to wait a lot of time for building our tools. And actually in monoliths, it was fairly easy. I mean, I guess most of you are Java or JVM people. So what we were doing, we were, for example, running Maven clean install. And then there was some magical deploy script, which throw it into our local application server, or maybe we run it from the IDE. So this excuse in monoliths was not really valid anymore, because even leaving Maven aside, we had good tools like just-in-time optimization, or we had tools which were swapping the code on the fly. We have incremental compilations or whatnot. And when we entered the world of microservices and the cloud infrastructure, things got a bit different. So we still could use our favorite tools for building the executable, but then next steps were added, which turned out to add more and more time into our inner development cycle. So we had to build an image. That was the first step, which was not really that frequently used in the monolithic times. Then the other is obviously we have to push it somewhere, because it needs to be available for our cluster to pick it up when we roll out the new version. And then the magical deploy shell script, which was probably written once by some guy, turned out to be a humongous YAML, which we apply using kubectl or OpenShift console tool. So there are few steps which, when you sum it up, it's not a matter of seconds, it's actually a matter of minutes. So we can drink coffee, right? We can Slack, we can drink more and more coffee, and we are not really productive. And if you drink more and more coffee, you start to be hyperactive, which I feel right now on myself. But you also do more stupid things with more energy. So the first thing, which is a build of your service, is addressed by several tools which we have available. There are tools from big players like Scaffold from Google or Draft from Microsoft, and there are also smaller startups which are providing similar capabilities. So there's Tilt Garden and GitKube, to name the few. Their main goal is to cut the time of building Docker images. So we are still kind of having a bit of wait time to do all the other things. But one of the problems, let's say, is somehow solved. But then, what about troubleshooting? I mean, when bad things happen in production, you have to take time to understand what's going on. So do you read the logs? Or maybe you look at tracing? I mean, all of these steps are actually post-factum, after-the-fact activities. So from the monolith times, we are all used to use our favorite debuggers. So the question is, can we apply the same in the cloud? And obviously, when we talk about deploying one service, we can easily just, let's say in Java, enable debug options and do the port forwarding. It's all good. But as soon as it grows and new languages are in, it's getting tedious. Luckily, we have some tools, open source tools, which you can use. And one of them is called Squash from Solo.io. And their goal is to simplify this boilerplate process of attaching debuggers to your services. So you can debug running microservices from VS Code or from JetBrains, and Eclipse is coming soon. And you have very similar experience as you used to have with your pet projects or monoliths. So in case of Java, there are two sides of the equation. So it's the one done by you, by developer, and then all the lifting is done on the server side of Squash, which is deployed to the cluster. So what you do, you open your IDE, you select the pod which you want to debug, and you set breakpoints. And on the server side, Squash will get the pods, add the debugger's options, and we'll start directing the traffic to your IDE. One downside of this is that you have to select the pod literally, so you have to know which one you want to debug. However, when you are using Service Mesh, they do have a filter where you just put the header, and then the Service Mesh will actually just attach it to any pod to which the traffic is routed. And in Golang, it's very much the same. On the IDE side, you just do the regular stuff, and the plugin on the server side actually knows that it needs to start up Delph and do some process enhancement to give you the debugging capabilities. But this way, you actually have your IDEs. You can debug multiple services at the same time and do the whole flow in the cluster. So far, so good. And it's tempting to run tools like Minikube or Minishift on your local machine so that you can have everything isolated and under your control. It's easy when you think about few services, but most of the times you are not dealing with 4 or 5. You're actually dealing with dozens. And even if there are little programs like Quarkus-based native image done by GraalVM or Golang executable, we can say it's probably 50 megs of memory per container. But if you have 100 of those, plus the cluster, plus Istio or whatever else is in the Kubernetes, your CPU is going to sweat. So it can happen that you will have your laptop on fire. Happened to me lately. I had 95 Celsius on my Intel, and I had to change the thermal paste. So it's something which I experienced. So the bottom line here is that you can't actually think about running everything locally. Even though we all desire to have a local developer experience, it does not make sense as soon as your architecture grows to run the whole, for example, Netflix. I mean, can't do that. So another tool which caught our attention, and it's also open source, it's called Telepresence. And Telepresence is a tool by a company called DataWire. They also do API gateway and other products. And the Telepresence, it's a bit magical. What it does, it sets up VPN locally, and it does some DNS magic to essentially gives you following experience. You swap your A service with the Telepresence proxy. So underneath this container will gonna be replaced by Telepresence proxy, and the whole traffic which goes to your service will actually go into your local process. And all the other interactions remain the same, except when you initiate a call to the service in the cloud, for example, an out service, it will all go to the cluster. So you have low memory footprint, you just run your local process, and all the other stuff is running in the cluster. So as soon as you don't use Minikube on Minishift to your local machine, you leverage the cloud, so somebody else's laptop. You have very low memory footprint, and your laptop will keep a reasonably low temperature. So to summarize all the small building blocks I just showed you, for improving the build where the Docker is involved, you can use tools from Google like Scaffold, you can use Tilt, you can use GitKube, Garden, or Microsoft Draft. For debugging, interesting point is to have a look at Squash, or if you want to use your favorite tools and everything, what you prefer to have local developers experience, then have a look at telepresence, because then you actually have your own favorite IDE, could it be Vim or Eclipse or IDEA, and you just debug the local process. You use everything you used to use when you were dealing with monoliths. So now to a bit of a war story, and why I'm talking about all these tools and why actually I looked at them, is that when I joined Red Hat, we started working on the software as a service, which was called OpenShift IO. And the idea of OpenShift IO is very cool because the vision is to take you from the idea to prod with little to no friction. So the tool provided you the planning suite, so you can think about it something like Jira, you could do Scrum, you could do Kanban, Waterfall. You could, you had getting started experience, which essentially means that when you start a new service, you have some template, you can select a technology, you can select some flavors like REST, like DB, and everything will be scaffolded for you, put in the Git repo, the project will be set up, and then the next step, the build will be configured, so you have a continuous loop of deploying it to your staging cluster, for example. And on top of that, we also had analytics service, which was scanning your dependencies and other vulnerabilities in the containers. But also Eclipse Chair, which is called Red Hat Code-Ready Workspaces these days. That's the product. And it lets you pretty much do everything in the browser what you used to do on your laptop using other IDEs. So pretty much comprehensive integrated suite. The reason why I'm talking about it in the past tense is that this evolved to part of OpenShift, which is called Dev Console, and will be shipped later this year, at least most of the bits, as an OpenShift console edition. You can already use standalone parts, like, for example, code-ready containers, which is Eclipse Chair. You can use analytics from VS Code and from IDEA, I think. But the ongoing work and the lessons we learned from OpenShift IO, we will become Dev Console. So we started with reasonably few services, and I wouldn't call them micro, because we didn't really know in great detail the domain, so we didn't want to come up with something which will be invalid very soon. We started with a bit bigger beasts. And we quickly noticed that there is lots of moving parts. There's several teams working on different areas, and there were a lot of conflicts or whatnot. Therefore, we have blocked PRs because some new stuff was deployed on the stage environment, but the other one was not yet adapted to it. So, we had to wait sequentially until stuff was promoted to the stage. And the cluster was giving quite a bit of problems due to this moving parts nature. But on top of it, all of the developers wanted to have this fast local experience. And as these problems were piling and piling up, obviously people got frustrated. Because you are not productive, you can't really feel like you are delivering. And I mean, if you stay in such an environment, I mean, people will start leaving, right? Because it doesn't make sense to waste time, unless you like to drink infinite amount of coffee, to stay in this state forever. So at this point, knowing the telepresence, knowing Squash, and knowing the other tools which speeds up the inner development loop, we started a bit of a research. Me and a bunch of other engineers, we kind of formed the productivity group, a bit sidetracked from the main effort, and the research had few simple goals. So what we wanted to achieve is have an easy way to validate, let it be tested automatically or manually, the changes without messing up with all the other versions and instances of the services. What we also wanted to have is to interact with the actual service in the cluster, which we don't have control over and we can't replicate the data, and they are the crucial parts which we all rely on. And also, as I already mentioned, write software locally with your favorite tools. So the entry point is OpenShift, which is a Red Hat Kubernetes distribution with a bunch of enterprise-grade additions. But then we also had, we picked telepresence. And we were looking at Istio. How many of you know Istio or heard about it? Okay, not so many. So I will show you one diagram and a bunch of pictures, and I also have few very valuable references, including the book by my colleagues from Red Hat, which is for free, which you can have a look. So Istio is a service mesh, which realized the vision of externalizing network and all the configuration outside of your service. So you only focus on your business logic, and all the, let's call it infrastructure aspects are managed by Istio. So the service A and service B, they don't know about the network addresses, they don't know if they don't configure what's allowed, they don't really have anything hard-coded about fail recovery. Everything of it is managed externally by the sidecar containers in Istio. Therefore, your business logic is pretty much the only logic you have in your service code, and all the rest is just externalized. So in a very quick overview, few important aspects which Istio provides is obviously security, so authorization and authentication and the rules and policies of which services are reachable by which others. You also get metrics, which are integrated with Prometheus, so you can, in Istio, just define what you want to observe, and this will be made available for you. The failure recovery is yet another aspect which Istio provides, so these are like circuit breakers, retries, rate limiting, everything outside of your code, so you don't have to use Hystrix or Resilience4j, even though you can, because it's handy. Other stuff which Istio gives you for free, or included, it's traffic mirroring. This is a very useful technique when you want to test a new version of your service, but you don't want to make it available yet for your users. So what you can do, you can have your service which is facing all the traffic, but then you have a new version which will be deployed in shadow. So it's called dark launches, the technique. And the traffic which goes to your service A will go to A prime, but this will be not then affecting the users, because the traffic is just duplicated. You observe if your new service behaves under the same conditions with the same responses, and at some point you can switch. Obviously, you need a bit more tooling on top of it. You might need to look at tools which will compare the responses. One colleague of mine created a tool called Differencia for that, which is inspired by a tool called Diffie from Twitter. It basically supports the concept of dark launches, where it compares requests and responses transparently and gives you an answer if actually your new service gives the same or similar response to what's running in prod. And the thing which was the most interesting for us as we were looking at this tool to simplify development experience is splitting of the traffic. So that under some circumstances, under some conditions, the traffic which you initiate will go to defined service, but not to the other one. So that's very much a whirlwind tour of what's in Istio, so that we have a bit of a common ground. If you want to dive a bit more, these are the two talks, a tutorial from Red Hat developers, and the book, which is for free. The slides will be available online. I will tweet it, so you can make a photo, but I will make them available. These are all clickable links. So. they should work. So here we are. Let's meet our brainchild, which is called Ike. So Ike is a command line tool which we researched on over the last few months, and it tries to realize this vision and the goals for having a way of unobtrusive testing of your service so everything else will not blow up, to have a way of local developer experience so that you can work locally and see instant changes without even the need of redeploying stuff. And it comes with two flavors. So first part, let's call it the backend part, is the operator. So the operator is a piece of code which sits in Kubernetes and observes some events and does some updates to certain resources. So in our case, it's fairly simple. We just create some custom resource called session, which I will show you a bit later, and we keep some data about the configuration there. And also we orchestrate deployments and swapping of containers, right? That's the main magic. And then there is a CLI, right now only a CLI, which gives you this local development flavor. And with that said, I think we can do the demo. It's a bit of a cheating demo, not much typing, but it's kind of interactive. So for the demo, I'm going to use the book info app, which is shipped with Istio, and it demonstrates what Istio has to offer. So we have just a simple catalog of books. Here you have details, we have reviews, and some general information. So you can somehow assume there are at least 2 or 3 microservices involved. Which actually is the case, because if we look at what we have in our namespace under OpenShift, there is a service called details, which is a simple image. Then there is a product page which serves all what we have just seen, ratings and reviews. And the next bit of OpenShift is called Kiali. That's an add-on to Istio which visualizes the traffic of your services. So here you can see that I entered from the main page, and the detail service and the review service of version 1 were reached. So far so good, but let's see what we can do in action. So we use the CLI tool. We want to install the operator first. It's fairly simple command. It will run the deployment. You will see there is a special namespace created called Istio Workspace, where all the magic happens, and there is an operator in there. The tool is called K9S, if you like command line. That's something which shows you your cluster details. We are done with operator. We are ready actually to start using the local developer's experience. So what we do, we simply start Kubernetes to see all what we have in the pods, which you have seen in the OpenShift console. You can see that there are some Istio sidecars, and now we can try to see what's this detail service doing. It's a simple Ruby, which we're gonna edit, and it just prints out the details of the book, right? So if I want to change it, what I do, I say Ike develop, then I say that's my deployment I want to change, which is details version 1, because that's the one which is available in prod. I want to say watch for changes in my root project directory, and then I say, if you have a route with header called end user Devoxx Poland, you will be redirected to this new service. So underneath, we start telepresence. We watch for changes in the code, and transparently by the operator, we can see that the new pod showed up, which is this one, and that's my new service. And telepresence started the Ruby thing underneath. And we have a new resource created, which is called session, and this is where we store all these configuration details. So we can have a peek in the content in the YAML format, pipe it to cat with a syntax highlighter. And yeah, you see that there is Devoxx Poland header defined and some routing rules. So one thing which I want to highlight here, with the headers, you get it out of the box when we are talking about handling is done out of the box, the routing is done out of the box if we talk about edge services, so the ones which you hit as a user. When you want to swap the services somewhere deeper in the network, I mean, obviously, you need to have some convention in your team about which header has to be propagated, right? Because otherwise you don't know if that's the right route. But in case of this example and most of the microservice architecture, you always propagate some extra headers, for example, for tracing, and book info has the end user propagated all over the place, so we will know what which version of details, which is not the edge service, we want to serve. In the CLI, I haven't shown you all the magic because you can also keep it in YAML, obviously, because cloud native is all about writing YAMLs. Basically, for the command develop, I run the Ruby program sitting on the port 9080. I say, hey, telepresence, forward this port to my local process, and this is my target namespace in Kubernetes. So now, when I have a look at the application, you see that in Kiali, we already have two versions, right? So this is our edge service, and this is the detail service, which we already reached as a non-authenticated user. But there is this new one, which hasn't been reached yet. So if I log in as Devoxx Poland, that's how book info propagates the end user information. You will see in a second that this was reached, the other one. And the next step for us will be to actually change the code so you see that this stuff not only works in the nice diagram, but also through the code changes themselves. You see that I was able to reach it. So now my goal will be to change the publisher A to Hello Devoxx Poland, for example. So what I have a service running here already, and I can enter Vim. I don't know how to quit, so let's see. I'm going to change it to Hello Devoxx Poland. And I do wyjdź kurde. If somebody knows Polish, that's the abbreviation you have to remember. Wyjdź kurde means write and quit. Then you see this was reloaded. We found the changes in the files. The process was restarted. So my next step here will be to check if I actually can see Hello Devoxx Poland when I log in as a Devoxx PL user. So I go back to my book info. You see that it's unauthenticated user, so he hits the V1 service. I log in as Devoxx Poland with any random password, doesn't really matter. And you see it's instantly changed to Hello Devoxx Poland. And I signed out, I hit the regular service. Quite magical. All right, then what we can do when we are done, we just kill it so that we see if we can clean up our mess. So here you see that actually the pod which we cloned is terminating. Underneath here, it's not the actual container of details v1, it's this telepresence proxy which will reroute all the traffic. So this is more or less how this works. It takes a while, obviously, because first and foremost, that's the local cluster, if you haven't noticed. And the provision scaling down, it's not an instant milliseconds operation. And now I can check if my backend actually has something. I don't have any sessions stored, so everything was cleaned up. And the pod is dead. Right. So now what we can also quickly see is if the Kiali shows, or if we as a user see the changes which we introduced. So I try to log in as Devoxx Poland, but you see that I'm hitting the old service right now. And in Kiali, the visualization of Istio services, the flow of the packets, it looked like it was before. There is no Bartek special event container. The name was actually auto-generated, so I don't know, randomly, so I don't know how it came up with event. Right, so this is pretty much what we have right now. So it's Istio and telepresence does all the heavy lifting so that you can work locally and test your changes without giving hiccups to the other users. The reason, so we created that because all the other stuff, Squash and telepresence, these are the building blocks. What we were actually lacking was this routing based on some preconditions so that actually only you or certain users can access the service, right? So with the IKE operator and some Istio virtual services and destination rules, we could easily define that if I go with end user Devoxx Poland, that's where I should redirect my traffic now. So the next steps we want to do is obviously not everyone loves CLI. I do, but I also use IDE. I actually don't use Vim that much. So we want to do IDE integrations. We're going to start with VS Code because then it will give us also a way of integrating it with Eclipse Gem and TIA. But what we would love to do as well is to see how this fits to CI/CD. If we need some extra work to actually let your builds and PRs that do exactly the same thing, so that you can test your changes in the actual cluster without spawning that much of the environment. So that's also what we are researching on. But first and foremost, and that's the reason I'm giving this talk, and it's actually the very first talk about this stuff, is that I want you to go and try it and tell us what else do we need, because we can't really sit in ivory tower and come up with fancy use cases out of nowhere. So the tool is on this GitHub, Maestra. That's the Red Hat downstream, so the Istio version of by Red Hat, which is gonna ship to OpenShift, and the project is called Istio Workspace, or you can just go to my GitHub account and see where I'm pushing most of the stuff these days. Just today we will release version 001, so it's not production ready. But it's ready for you to give it a try and see if it fits. I mean, Istio is production ready, telepresence is used by quite a bit of companies. We are just doing some nice plumbing on top. Now, are we geniuses? Are we innovating here? Sadly, not quite. We are not alone. The tool we built was actually kind of overlapping and was partially inspired by the work of a company called Namely. There was a talk on OSCON last year by Robert Rusk. His nickname is Bobby Tables. I will link the talk in the slides. But he pretty much describes very similar workflow, except that our key differentiator is that we are open source. So you can just grab it, use it, maybe help us somehow, but it's all for free. Microsoft is doing very similar activity with Azure Dev Spaces, and from what I learned and how it looked to me on Monday, Google with their Cloud Code are addressing the same problem space. So then, what about the prod really? I mean, I showed a few things which you can use in whatever flavors you want, but how does it relate to prod? I mean, the staging environment in general is a challenge. I don't know how many of you are having not only prod environment, stage or QE. Are you happy with it? Is it reliable? Raise your hand. And that's exactly what I want to solve with my friends. Because it's very hard to keep it in sync. It's very hard to guarantee that it's similar to prod. And even if you deploy to prod and bad stuff will happen. We are all human beings, we do mistakes. But it also costs extra money. I mean, cloud is not for free. You have physical resources underneath. So that's another extra effort. And even with all the automation, there are some ops people involved to keep this stuff rolling. And there is still uncertainty when you go to prod. I mean, I'm having some nightmares here and there when I ship some new, or I used to ship some features in my past life. But also, with all the tools I showed you, so with Kubernetes and Istio, and the approach we have with telepresence, you can somehow maybe not eliminate, but at least mitigate a lot of risks which staging environment was designed to solve. Obviously, the example I showed you is some stateless Ruby file. So for stateless stuff, it works. We don't have a universal answer to stateful, though. I mean, I could say it depends, because it actually does. Most of the things you have to solve within your own architecture, but there are tools like, for example, JBoss State, which is DB layer virtualization, which you can use to, for example, clone database tables, and you read from prod, but you dump to the new one. So there are tools and techniques which are available to investigate. We would like to have some answers, and I guess at some point of time, as soon as we get people using it and showing their own use cases, we would be more than thrilled to create something usable for everyone. And I think that's all I have for today. Thank you very much for coming and staying with me. I hope you enjoyed Devoxx as much as I did, or even more, because I was freaking out preparing the slides most of the time. Have a safe travel, apply most of the things you learned, and keep learning. Thank you very much. If you have some questions, I'm here. These are my coordinates, not really readable, I think. But you can grab me on GitHub, Bartosz Majsak, and Twitter is a bit of a nickname, Myson. I work for Red Hat. Thank you very much, and have a great rest of the conference, right? Thank you.